Assalamu alaikum students. In this video you will learn about different types of variables. These variables are used as data in the form of tables with the help of which you all can draw different types of graphs. So let's see which are the types of variables and which graph is suitable for that type. So variables, that is our data, is of two types: qualitative data and quantitative data. In qualitative variable or qualitative data, you have the data with the help of certain words like larger, smaller, medium, near, far. So words are used in qualitative data. While in quantitative data, you have numbers. In quantitative variables, again you have two types: discrete and continuous. You can only have whole numbers in discrete variables. When a variable can take any number like time or distance, then it is called as continuous data. We also have one more type of variable, and that is called as categorical variable or categoric variable. Categoric variables are words but not numbers. So categoric variable is a type of qualitative data. In categoric variable, you may have any ordinal or you may have a nominal. Like you may have information about number of pens, number of pencils and erasers in a classroom. So that data is a categoric data. Or you may have the number of pets, given information of number of pets in a table. So number of cows, number of dogs or number of cats. Similarly, words like excellent, good, bad, fantastic, okay, don't use. These words can also be used and they are part of categoric variable. Now let's see, as per the type of the data, which is the suitable graph which can be plotted for the given data. If the data given is a discrete data, that means it's not dependent on others. It's an individual number. So here in discrete data, they are the numbers. They are simple whole numbers. So for such discrete data, bar charts is the most suitable graph which you can use for discrete data. You may also have a pie chart if the data is discrete. You may have a line graph for a continuous data. Let's see a few more examples of discrete data and continuous data. If the number of pages of different books, such information is given, then your number of pages will have a value, will have a number. It will be a whole number. So this data is a discrete data. So example 1 is an example of discrete data. So this data can be shown with the help of a pie chart or a bar graph. If you see example 2, length of a film. So here length of a film will depend on each other. The length of the film may increase or the length of the film may decrease. So here one variable is dependent on other. Yes, it may take any number. So the variable which takes any number is a continuous variable. So second is an example of example 2 is of a continuous variable, and in order to show a continuous variable with the help of a graph, line graph is the most suitable one. Example 3, shoe size. So a shoe size is a fixed number. The shoe size can be 5 or 5.5. It can be 6, 6.5. Yes, not any number between those. So here, since the sizes are fixed, again it's an example of discrete data. Temperature. So if you're boiling something, the temperature, let's say if you take water in a container and you start boiling, what will happen? The temperature of the water will go on increasing. So here the temperature may take any value. So it's an example of continuous data, continuous variable. Example 5, number of people in a race. Number of people in a race are fixed before the race starts. They can be 5 people or 10 people or 15. It's fixed. So here number of people in a race is an example of discrete variable. And the last one, time taken to run the race. Now every runner will take different time to reach the final point of the race. So here the time taken can be any variable, okay, it can be any number. So here this example 6 is of a continuous variable. So example 1, 3 and 5 are examples of discrete variable. They can be represented with the help of bar graph or pie chart, while example 2, 4 and 6 are examples of continuous variable, and the most appropriate graph is the line graph to represent that data. Now let's see what are timing gates. These are the images of timing gates. Timing gates, if I tell you in simple words, they are the digital devices which are used in races. Okay, timing gates removes the errors made by reaction time. That means if in a race is happening and 2, 3 runners, they reach the final destination at the very same time. Yes, just the difference is fraction of second. So that difference cannot be seen with the eye of the judge because they are very close. So such difference or the accurate time can only be noted through devices which gives you the exact time, and those device is called as timing gates. So these are the images of, this is an image of a timing gate which are placed in races, and usually they are placed at the final destination, that is the end point of the race. And when the runners they reach the end point, they immediately give a flash and they reflect the exact time when the runner reached the final position. As you can see here also, the timing gates are used in the sports games, and they give you the exact timings of the runners, or it can be also used in other sports events. Now let's see question number 9, textbook page 93. A tortoise travelled across a path 1 meter wide in 10 minutes. It then rested for 2 minutes and went across a 2 meter wide piece of grass in the next 8 minutes. So, two distances and two times are given. The first distance and time is for the tortoise which crossed the path. And then after resting for 2 minutes, then later on, it covered a distance 2 meter in 8 minutes. So the first question is question 9a. How fast was it traveling when it crossed the path? So here how fast means you have to find the speed of the tortoise. So here speed of the tortoise on the path will be, the formula for speed is distance divided by time. So it will be distance divided by time, it will be distance is 1 meter. So 1 upon time is given in minutes. So we will convert minutes to seconds. The time is given as 10 minutes to cross the path. So we write the value of time, that is 10, and multiply it by 60 to convert it to seconds, because the units of speed is meter per second. So when we divide 10 into 60 is 600. When we divide 1 by 600, we get the value of speed of tortoise on the path is 0.0016 meter per second. Question 9b. How fast was it traveling when it crossed the grass? So you need to find the speed of tortoise on the grass using the last two values, using the distance 2 meters and the time is 8 minutes. So again the formula of speed remains the same, that is the speed is distance divided by time. Distance this time is 2, so 2 upon time is 8. Again here if you notice, the time is given in minutes, so minutes have to be converted to seconds by multiplying by 60. So 8 into 60 gives you 480. So 2 divided by 480 gives you the answer of speed of tortoise on grass, that is 0.0041 meter per second. So as you know, tortoise walks very slowly. Yes, that is why the speed is in points, 0 point. Question 9c. What was the average speed for the whole journey? The formula for average speed is total distance upon total time. So we have two values of distances, that is 1 meter across the path and 2 meters across the grass. So we will add to get the total distance. So 1 plus 2, and the total time along with the resting time, because in the whole journey the tortoise took rest also. So in average speed we will consider that time also. So 10 minutes, 2 minutes and 8 minutes. So 10 plus 2 plus 8 gives you 20, and then again 20 is minutes, you need to convert it to seconds, so multiply 20 by 60. So 6 2s is 12, so 1200 you will get it in the denominator. So 3 divided by 1200 will give you the answer of average speed as 0.0025 meter per second. Next question is, Nadia is looking at question number 10. Same page, textbook page number 93. Nadia is looking at some information about scooters in a showroom. There is information about the color, the top speed, engine size and manufacturer, and also the cost. She makes tables to show the value. So Nadia goes in a showroom to take a new scooter, and she makes the table and she writes the information about the scooters. So she makes the table of the color, the engine size, the cost, the manufacturer, the scooter manufacturer tables. So table A, B, C, and the fourth table she made is table D. So the first question 10A is, which two tables of data can be used to plot line graphs? So as I told you, line graphs needs the data which is continuous. It can take any value. So let's see the first table. Table A it doesn't have only numbers, it's having color also. So table A cannot be used. Table B, yes. Cost of the scooter can be any cost, it can take any value. Engine size can also take any value. So here the table B shows continuous data. So table B can be used to plot line graph. Table C, no, because the names are given of the manufacturer. And table D, again, yes, the table D is also, yes, in table D, the data is again a continuous data. So table D data can also be used to plot line graphs. So the correct answer is table B and D can be used to plot line graphs. So if table B and D are used for line graphs, in question number B, they are asking you which two tables of data can be used to plot bar charts or pie charts. So leaving table B and D, the other charts can be used for plotting bar graph or pie chart. So table A and table C can be used to plot bar charts or pie charts. The next question, question 10C. What has Nadia missed out of her tables? So here it's a general question, of course not linked with the types of variables, but then fuel consumption is missing in the table. So before you purchase a vehicle, you should also know the fuel consumption of the vehicle. So that can be the answer for this one, that the how much fuel that scooter is consuming, it should be economical for the person to buy. If it's using more fuel, then more money you will spend on the vehicle if you travel with that vehicle. So fuel consumption is the answer C. Question D. Which of the variables are categoric variables? So what are categoric variables? They are variables which are having words in them. So let's see. Table A is having words. Yes, it has colors, red, blue. So table A is the color is the categoric variable. And again, next, which information is in words? From table C, manufacturer. The names of the manufacturer, Speedy Scooter and Scooter Land. These two are also words. So they are also part of categoric variables. So the correct answer is color and manufacturer are categoric variables. Next question. Question 10E. Name one of the continuous variable. Continuous means which change, which go on increasing. So here if you can see table D right on the top here in the image, speed. Speed can be a continuous variable. Speed can increase or speed can decrease. So increase and decrease, it's a continuous data. So speed is a continuous variable. Next question, question 11. Here is the speed time graph of a car. So recall the speed time graphs which I had taught you in my earlier videos. The first question is you need to say which statement is true and which is false. Let me quickly revise. If the graph line is going upwards, the car is moving at a high speed or steady speed. If the graph line becomes flat, it shows that the object, the car is stationary, it's not moving. And if the graph line is coming down, that means the speed of the car is decreasing. So let's see now. Let us read these sentences and say whether they are true or false. Question 11A. The car is stationary in section B. So if you see in the graph, where B is written, the graph line is flat. So yes, flat line means the car is stationary, so it's true. So first answer is true. Question 11B. The car is slowing down in section C. Yes, if you see section C where C is written in the graph, the graph line is coming downwards. Downwards means speed is decreasing. The car is slowing down. So again the B1 is true. 11C. The car is moving at a steady speed in section A. Section A, if you can see the graph line is going upwards, that means speed is increasing. But in the sentence it is given that it is moving at a steady speed, so it is false. 11D. The car is moving at a steady speed in section B. Now, if you see section B, B line is a flat line. Now, there are two possibilities when the graph line is a flat line. When the line is flat, the car is stationary or it is moving at a steady speed. So, D1 is again true. And the last one, in section A, the car is moving with steady speed, that is slower than the steady speed in section C. So that means they are saying that speed of car A in the section A is less than that of C, so it is false. At the position A, the car speed is the highest because the slope of the line is more. The line is more steeper. So answer E is false. Last question, question 12. A student records the time that it takes different types of balls to fall through a distance of 1.5 meters. He writes down these results. So what is a student doing? A student is taking three types of balls: tennis ball, football and table tennis ball. And then he allows the ball to cover a distance of 1.5 meters. Okay, He's standing at a height of 1.5 meters, and then he's throwing tennis ball, then he's throwing football, then he's throwing table tennis ball, and then he notes the time, how much time those balls are taking to come down on the ground. Question 11, 12a. The student should have used a table to display his results. Draw the table and put the results in a data. So let us see how we can make a table to represent the given data. Yes, so here we can make a table where we can write the first column can be distance. First we have to make 3 vertical columns, where the first column will be vertical, see the vertical ones, tennis ball, second will be for football, and third will be for table tennis ball. And then what is given? The distance of all 3 balls. The distance covered by all 3 balls is same. So in the distance column we write 1.5 meter for all 3 balls. Now time taken by all 3 balls is different, so we will insert that value in the table. So for tennis ball, it is 0.53 seconds. Then in second one, for football, the time taken by football is 0.68 seconds, while for table tennis ball it is 0.72 seconds. So I have clubbed answer A and C. So answer C says that, before I proceed to B, let me take on question C. Calculate the average speed for each ball. We have to find the speed of each ball. So that I have done it in this table only. The formula for speed is distance divided by time. First, to find the speed of tennis ball, you have to just do 1.5 divided by 0.53. So it will give you the speed as 2.83. And the units, you can write it near the word only, near the speed only, that is meter per second. So for football, to find the speed of the football, you have to take the distance and divide by time. So for football, the distance is 1.5 and the time is 0.68. So 1.5 divided by 0.68 gives you 2.2. And finally, for table tennis ball, the distance is 1.5 divided by time, that is 0.72. So distance divided by time will give you the speed of table tennis ball as 2.08. So this is how in a table you can write the distances, time, and then find the speed by dividing distance and time. Question 12b. The student used timing gates to measure the time. How do timing gates work? So I just explained you that timing gates, they give you exact results because they don't respond as we respond, that which is called as reaction time. Yes, we respond to the instructions given to us in a different manner. When you listen something, some will do it very fast, some will do it very slowly, some will do it not so fast, not so slowly. That means we have our different reaction times, but timing gates are not such. They give you these accurate results. Okay. And the last question, question 12d, is which graph would you draw to show the average speed of the balls? Explain your answer. So if you see the answers of speed, they are in numbers and their speed can increase or decrease. Yes, so it's a continuous data. So for continuous data, which is the most appropriate graph? Line graph. So the correct answer for 12d is line graph. Thank you.